Hello and welcome to TidyX episode 13. Wow, we're already at episode 13. All right, TidyX is a screencast that is dedicated to explaining how our code works and making it more accessible to everyone. All right, my name's Ellis Hughes. I am a statistical programmer at Fred Hutch Cancer Research Center. You can find me on Twitter at Ellis_Hughes.
And I'm Patrick Ward, and I do data analysis in sport. And you can find me on Twitter at OSPPatrick. And you can get in touch with the both of us, questions, comments, etc., at tidy.explained@gmail.com.
All right, so this week's Tidy Tuesday data set that we're going to be going through and explaining is on Marble Run. So this is a kind of a fun little thing, since we don't have sports right now. John Oliver, this was highlighted in John Oliver's last week tonight or something like that. Sorry, I don't watch it, but it's on Marble Run. So what they're doing is they're racing marbles down these created tracks, and it's really funny. I've seen a few videos. It's a lot of fun. Like they have a commenter on it going, "Oh, look at this, look at that," and so it's a lot of fun to watch because right now we're obviously all missing sport right now. And so they posted the data set, and a lot of you had some pretty fun visualizations. I think we saw one that was like an animation of the marbles going um, around a track,
Yeah.
and so
I,
that
I
was
don't. I wonder if those were the actual. I've never watched the show. I wonder if those were the actual tracks. Somehow the person got the actual tracks, or went. I wonder what. Yeah. I
I'm
don't
not
know.
sure, but that was pretty fun, I thought,
Yeah.
and pretty creative. But we felt like that might be a little bit advanced. We'd have to talk about that for a while, but we got the opportunity to do another post, and it's one of the first post ideas that we saw suggested for this data set, and then a person that I know I look up to for Tidy Tuesday because his submissions are always super fantastic is Cedric Scherer. And so Cedric created this bump plot using the package ggbump or bump, excuse me, bump
Oh, yeah.
with a B.
Mm-hmm.
And he created this beautiful visualization of showing how the different marble teams across this Marble Olympics performed across the 8 different races that existed. And so I thought this was a lot of fun, and I also thought this would be great for showing not only how to create a bump plot, but then also his code is incredibly clean. Like we didn't touch anything, and it just looks gorgeous. Um, and
Much
so,
nicer than mine.
so I really wanted to take this opportunity to go through and explain how his code works and the formatting, because that is so critical to sharing information, is writing pretty code, because pretty meaning it's really easy for people to digest and understand. All right, so Cedric makes his code available on his Tidy Tuesday repo on GitHub. So we went to that repo and pulled it down and opened it up in our RStudio instance right here. All right, first things first, you'll see that he is using an R Markdown to run all of this. So that means he can just run a click knit and it'll rerun everything for him real nicely. He's got some editor sections up here defining how he wants it to behave, but that's up to personal preference. This first chunk here that he's doing is he's setting the options for knitter. So he's saying that he will always wants to, by default, show the code that it's running. He does not want it to show that warnings that pop up, because those can be obnoxious in your final report. You don't want to really see them. And then he's setting the figure retina and figure show text to true. Not quite sure what those do, but I'm sure there's a reason behind them. All right. So then right after he sets those knitter chunks, he starts loading in his packages and kind of setting up his environment the way that he wants it to behave. So he loads library tidyverse, library ggbump with a B, not to be used as ggbump, though that now needs to be made. Not quite sure what that would mean. So ggbump. I'm going to keep on saying this. I'm sorry. ggbump is an extension to ggplot that'll help you create these bump plots. And so it's a fun thing here. And then he's got library show text. So let's load those in. He is setting the fonts that he's going to want to be using. So he wants to use the Oswald font. And then what he does is he sets his theme. So this is the thing that, Patrick and I do in our examples as well, where we want all our plots to show up with a specific theming kind of preset, and then we can kind of tweak them from there. And Cedric's doing the same thing here, where he's using a theme void, and then setting the family of text that he wants to be using to Oswald. So he sets that there. But then here's a new piece that I hadn't used before, so I had to quickly look it up. In fact, let's do that again. So what theme update does is it'll take the active theme that exists and then apply new theming to it. So then you can say you wanted to use like a pre-created theme and then change it slightly because you're like, I want the base or the background color to be blue instead of base white or something like that. And so rather than having to create your own theme, what you can do here is do theme update and add in additional themings to overwrite how it says it should behave for that one specific part of the theme. So what Cedric's doing here is he's setting, okay, I want my text for Y to show up like this with this margin and this size, this color. Same for all the other texts that arrive or show up around there. He wants his margins around the plot to be a specific size. He's setting the colors, so the background color of his plots to always be black. He specifically uses fill and color. That means the entire background will be black. If you just use fill, there'll be a white little edge around it, and so this color equals black is important for setting that. He sets the color or the plot caption and everything around that. So now he's got his plot set up, so he has to do like minimal theming later on that he has to worry about. All right. So now he loads in the data. This time he's using the slug that Thomas posts. You can also use the Tidy Tuesday R package, which has now been submitted to Gran. So we're waiting for that to come out, and so hopefully then people will be able to just do install.packages Tidy Tuesday R, and you can just use that a little bit more simply. All right. So now he does some data prep, and this is a little bit confusing. Patrick and I discussed back and forth to make sure that we felt like we understood what was going on. Patrick, do you maybe want to take them through this?
Yeah, so he takes the DF Marbles data that he just downloaded from Tidy Tuesday GitHub repo. He selects out the key columns that he's interested in using for his data analysis and plot. Does a little bit of a filter here, string detect in the column race anytime there's an R. I think in the data there were other types of events in there as well, so there was some weird data, so that's why he's doing that. Group by, so he's grouping by race and team, and then he's going to team name, and he's going to summarize the unique number of points for each race and each team. He then does another group by team name, and then he arranges the data by team name and race. Each team had a few marbles competing, so that's why he's trying to aggregate points over all of these teams to sort of get a ranking. And that's where he goes down here and does this little mutate where he sums up all of the points. That's going to give him the team's points for the season, I guess we'll call this, for all of their marbles that competed. And then we have the points cum, where he uses the cum sum, which basically gives us sort of a rolling aggregation of the number of points that each team is collecting after each of the races. He then does another group by here, group by race. He arranges it by points cum descending and points sum, or so total points. And then this here is a way you'll see in our individual example, we use the actual rank function. But here, he arranged the data the way that he wanted it. And then he uses this row number, which basically is a handy-dandy way to create a row index. So for each row, it's depositing a new number. So because he's arranged the data by in the order that he wants it, that row number is going to effectively be the rank of that team. So pretty cool little trick there. He then ungroups the data, and then he does a little bit of kind of cleaning here where we're doing some string remove. We did a lot of that last week with Thomas Mock on data cleaning as far as what string remove is doing. So he's just removing that looks like S1R text from the string within that race column. He does a little bit of a reordering of the factors. So he's reordering the team name by the descending points sum. And then he's creating this cool little abbreviation. So you'll see in the plot, or you saw in the plot, he creates at the end of each line the team abbreviation. So this is like a nice way of just sort of alleviating any sort of messy legends that are going to happen or stuff like that. So he creates these cool little abbreviations using a case when.
Mm-hmm. I think we talked about this last week, and I know we got a question about it. I think it got deleted, but somebody asked us how you maybe could do, rather than doing a case when, you could do a left join. And so in this situation, you could do left join. Say this was gone, right? Let's just delete that off. So you could run marbles rank, and then you can do a left join, or let's marbles df marbles rank. Mm-hmm. Sorry, I'm going off script here. And then you could do a tibble, or let's do triple because those make it nicer to format. And then you could do column team name and column team abbreviation. Then you could do the team name here, so whatever one of the team names was as a string. Mm-hmm. And then the team abbreviation. And you do this for each of the teams. Mm-hmm. All right, so then you end up with a triple or a tibble that has two columns. And then you define, I want to do the joins by team name.
Team name, yeah.
And so then this would be a way to add in the team abbreviation into your marbles rank. Of course, you have to output that to an object to save it, but
yeah, it seems like more steps than you need, isn't it?
Yeah, in this case, yes. I just wanted to bring that up since somebody asked about it.
Yeah.
So let's undo all those changes that I made, because what Cedric did is perfect.
There we go.
Let's rerun that. All right.
All right, cool.
So here he's defining a bunch of the colors that he's going to want to be using. And so each one of these is going to be representing a team color. I think he got this from the data set, or he looked it up himself. Mm-hmm. So now he gets into the actual plotting itself. And I think the way that he laid out this ggplot, I thought it was really easy to kind of step through and with Patrick and try to explain what was going on. And so we could understand it really clearly. So I like the way that he laid this out, where first he takes a df marbles rank object and sends it into the ggplot, which is pretty standard, but the way he laid it out, where it's ggplot2 aesthetic, and then each of these arguments here has their own line, makes it really easy to read and understand what's going on without having to, oh, well, all right, then it was rank, and then it was this, and you can just immediately see where everything is at.
Yeah. Also helpful when you get errors, because it's going to be assigned to a specific line. Whereas if all of these aesthetics were on one line, it makes it harder to figure out where the error is.
Exactly. All right. So he puts in the data set. His x-axis is the race number, which is a numeric value. Y is the rank of the team. Mm-hmm. Then he's going to set the color and group to be the team name. Next, he add this annotation here. So if you look at his, well, I guess I'm getting ahead of myself. So he adds this annotation here where it's a text value. He's setting the x and the y axis or locations, and the label is Marbula 1. And he sets the size there. So now this is basically putting text in the background of the ggplot, or of the plot, saying Marbula 1. And so I thought that was a pretty cool thing. I hadn't really seen that before.
Yeah.
This next step here, Patrick and I had to think about this for a little bit. What he's doing is he's drawing these segments that is defining the vertical and horizontal lines. And so if you look at his theming later on, you'll see that he actually blots those out. And that's because he wanted, what we surmised is that he wanted explicit control over the way that your X and Y axis lines looked. And so he's drawing a table or a tibble where he's defining the x and the x and x end and y and drawing these aesthetics there. So it's going to draw a line between x and x end and y. So these are a bunch of horizontal lines here that are going to be gray and very, very thin. Same idea with this geom segment. He's drawing a single vertical line. And then he adds this geom bump. And so that is the workhorse out of the ggbump package. And this is like the heart of the plot here. And so what he's done is he's added this Marbula one in the background. He's drawn his lines, and now he's drawing over that the geom bump plot there, and he's defining the smoothing. So geom bump will by default draw straight lines between all the segments. Here it's going to smooth it out and draw more curvy lines, so it looks, maybe a little bit aesthetically pleasing. Next he adds geom point, so now this will draw a little circle. He sets his data set to be limited to only the first race in this layer. Then he draws another point as well, but this one's only on the last race. So you're going to have a small little dot in the first race, and then this one is drawing this shape 21 is a hollow circle essentially. And so he's able to define both the outer color, which is defined by the aesthetics, and then the fill, he's telling it to be black. So it'll be a circle with a black dot in it, with whatever color the team is. Then he adds this geom text. So he's going to be drawing them at the... so what is the rank of the team at race 8? He's defining the aesthetic, so he's kind of bumping them over 0.11 races over, and is drawing the team, or putting the team abbreviation in there. And then he's also going to be adding the rank. So this is adding the team abbreviation, and this is the final rank of the team at race 8. Then one thing that Patrick and I had not seen before, I mean, there are a lot of things we haven't seen because Cedric does such great work, is this clip off. And so if you look at his plot, the Marbula one is wider than the actual plot margin, and this allows the Marbula one to be shown across all of it. It doesn't, clip it off and make sure that it has to exist within there, and then the rest is invisible. He's setting his X and Y coordinates here. He's flipping the Y-axis because otherwise it would be going from the bottom up 1 to 16, and he wanted it to be flipped, so the top ranked team was listed on the top. He's setting the colors because we hadn't done that yet, or we said that the colors are based on the team, and now he's actually defining what those colors will be. And then by setting guide equals F, that's saying he does not want a guide to exist. He just wants the colors to exist. And he's setting the labels. So let's quickly run all that. All right, what did I do? What did I not?
I think you forgot to run the colors.
Yeah, that's on me.
There it is.
And there we go. There is this beautiful plot.
Very cool.
Displaying it. There's the empty circle with the black dot in the middle.
Nope.
Remember the one, his visualization. Great plot, super fun. I think that this is a great example of how to use ggbump and really also start working more into those aesthetic and defining how you want things to look, which is an important piece of plotting, is spending time. You can't just don't always just throw out like a geom point and go, all right, cool, it's good. You can have some fun with it and really make it pretty and powerful.
Yeah, awesome.
Then he does saving it as a PDF and converts it to a PNG, because PDF outputs I think look a little bit can look a little bit nicer than just a PNG output. And so he saves it as a PDF and then converts it into a PNG so that he can put it onto Twitter. And then an important aspect that he does, he captures a session info which records the version of the package that you use, so you can always go back and reproduce your plot with those versions. All right, cool. Wow. Well, thank you so much, Cedric, for letting us go through and explain your code. I think this is incredibly valuable for a lot of people to see how you approach building your beautiful, beautiful plots.
Yeah, it's awesome. Good stuff.
All right. So now we're gonna use the same technique. I'm gonna restart my R session so we don't get any crossover. We're gonna now get into how we might use a bump plot.
Yeah, my code's not as nice.
No, it works
Sloppy.
well and it's pretty, and you're able to write it. That's the important bits.
That's it. Yeah, exactly. Exactly.
All right, Patrick, you maybe want to start us off?
Yeah. Yep. So obviously, as we start out, we'll run our packages. We're going to use. I don't even know why I loaded our reshape 2. I didn't end up needing it, but we load tidyverse rvest, and as Ellis said, we set our theme up top. Theme light. This could be any theme that you like, though. Theme classic. Theme BW could be your own special theme, like Cedric did. So we're going to go through this sort of as a back and forth. This is how I scraped web data from Pro Football Reference for this week's TidyX. And generally, we tend to do these things the way that we're most comfortable. So when I first started scraping web data, I did it primarily with base R type of functions, and this is how I do it, and this is how I kind of still do it, even though I know there's a more tidyverse appropriate way. So we're going to go kind of back and forth, where I'm going to walk through how I did it, and then Ellis is going to take you through the tidyverse way, so that you know both ways. Mm-hmm. So the first thing I did at the top is I specified the seasons that I was interested in pulling combine data for. So there I specified everything from 2000 to 2020, basically the most recent combine. And I create my URL using paste here. So if you were to go to profootballreference.com/draft/ it gives you a slash, and then it gives you the year, and then a hyphen combine.htm. I'm going to paste that together, and you can see I broke the Pro Football Reference HTML, and I put year in there so that it would basically paste each iteration of year that I specified above. So now I have essentially what is an HTML for each of the years from the 2000 combine through the 2020. And then I write this scrape function, which uses the lapply, and I pass it each individual URL. And for each URL, which I define as I read the web page using the read HTML function from rvest. I then identify the nodes, which is the table, and I then scrape that table and I dump it into this data frame. And I do a little thing there at the end where I called a draft year. So I take the substring out of each of those HTMLs that I have there, and I basically say, at position, scrape everything from position 46 to 49. So that'll give you the 4-digit year that I'm scraping out of that. And so we can kind of run all of that a bit there.
Oh, a little bit far there. Let's keep it to your code right now.
Yeah. Let's not get ahead of ourselves.
Yeah. Well, I mean, this is part of it too. Let's discuss this while it's still running.
There we go. It's all done. So then what I did here is I took the results from Combine Scrape, and I used this do call function, which basically says, take that first function there, rbind, which is a row bind, or in tidyverse, it could be bind _ rows. But I take the rbind function and I pass it to the Combine Scrape data, and that just puts it all into a nice data frame for me. So we can run that, and then we can run the head of that and see that we have all of the data pulled from that table. And then obviously glimpse, which is the line below, is going to give us, tell us what we're going to have to do for data cleaning. You can see it brought everything in as a character, so we're going to handle that kind of in the next chunk. But first, Ellis will talk about the tidyverse way of doing what I just did.
Yeah, I don't know if it's a tidyverse way. It's just the way that I like approach doing it, because I like to break down, like, what is the thing that I'm going to be iterating over.
Yep.
And for us, for this scrape here, what we're going to be iterating over is the year. And so what I like to do is define a year. We already defined that earlier. It's, 2000 to 2020. But then I know that I'll be iterating and generating this URL every time. And so let me back up, I guess, for a second. So I pass year into this function mapdfr, which is from the per package. And so that allows for functional programming. And so mapdfr says, okay, I'm going to input something to iterate over, and it will take the outputs. They must be a data frame, and it'll R-bind it together for me. So it kind of cuts some of the steps that Patrick had to do there, specifically this do call R-bind, so I don't have to do that. And so
I think doesn't it also map? Can't it handle, like, let's say we did this all the way back to, let's say, like 1990, and some of the columns had changed, or maybe they had less columns than they do now in the past 2 decades. Can't map handle that? Like, doesn't it just create all of the columns and just deposit NAs where, like, my do call would fail in that instance? I think it can.
I think mapdfr should be able to handle that. I'm pretty sure bind rows, that function bind rows, I know is able to handle that. I've done that.
Okay. Got it.
So, but I wouldn't be surprised if this is like actually calling that underneath the hood.
Yeah.
So create the same URL that Patrick was, do the same scraping, but because I'm passing year, I don't have to scrape it out. So I'm just able to drop it in as the variable that I was using. And so this is a really powerful way to do functional programming, which is kind of what R is based off of. And you can create all these, quote, anonymous functions because they're not assigned to a function name, and extract all that information. So we're going to get the exact same results. Not sure why I ran that. All right.
All right. So the next thing I do is I just collapse some of the position groups, mainly for ease of plotting, really. So I'm going to take all of the offensive line positions, for example, offensive tackles, guards, centers, and call them offensive linemen. Linebackers, I'll collapse the inside and outside linebackers into linebackers. The defensive backs will be represented by anybody who's a safety or a cornerback. Pro Football Reference does this thing where they call these guys edge players, which is defensive ends. And then if you're looking historically, sometimes they're outside linebackers that are pass rush sort of specialists. So they call them edge players. You'll see that there's a bit of an issue with this. We'll talk about that when we get to the plot. And then the final one is anybody that was called a defensive tackle or a nose tackle. I just designated them as a defensive lineman. And then anything else, we just keep it as whatever the original position was. So wide receivers stay wide receivers, tight ends stay tight ends, etc.
All right. So I did the same exact thing that he did, but rather than using a series of nested if-else statements, I used case when. And so I'm doing literally the same exact thing that he did, but this time we're using a case when. There are various times when a case when is clear. I think in this case it is, but we're also lucky that there are no values that return NAs. Because case when forces you to be outputting the same object type. So all of these things on the right-hand side need to be characters because we're defining them as characters. If else does type conversion for you, so you could have called this a factor for some reason if you wanted to, and then it would convert all of these other guys into factors, I believe. But if else does type conversion for you, case when, and that can be a benefit. It can also be a negative if you're not expecting it or aren't prepared for it. Case when forces you to actually deal with it, and so that can be a positive. Is you're not gonna. It removes the potential for weird results. I've seen cases where people are dealing with date objects with an if else. And it'll return a numeric value because the base object of a date object is a numeric value.
Mm-hmm.
And when they're being added into, I have a whole blog, or I have a blog post about this on my blog, thebioengineer.github.io, if else or if else. And it explains, it goes into more detail about that.
Yeah, but we can link to it in the show notes.
Yeah, it does type conversions strangely.
Yeah. All right. Then there's just a little bit of data cleaning here. This, I didn't really need to do. I thought I was going to do something else, and then I ended up not doing it. But we'll just go over it for the purposes of showing it. We've done this before. We take a column called the column called drafted.tm.round.year, which basically defines the information about the player's draft status from that season. And all I do is I separate that column out into 4 different columns called team, round, pick, and year. The within that string, I'm separating on the slash mark, and then what I did from there is I created I also didn't keep the original column in that separate function, so we could have kept it, but I didn't. Mm-hmm. I then do this mutate here where I want to just get out round. So everything in that was like it's like if you looked at the original column, like 1 RD, 2 RD, 3 RD. So I just wanted to remove that. So I just take the first value, which is 1 through 7. And then anywhere where it's an NA is representative of a player that was a free agent, so did not have any draft information. So I just do that. Again, we didn't use it, but it's fine. Then moving on to this next one, I wanted specific columns, so I get things like player position, or POS, weight, their 40, which I did a little name change there from X40R to 40, and their draft round and their actual draft year. Mm-hmm. I just did 3 little quick convert these to numeric. You could have done this in Tidyverse. Ellis has we'll show you how to do that. Actually, this is a newer way of doing it. Usually I would have done this in Tidyverse with like a mutate at function, but go ahead and walk through the across function there.
Sure. So this just came out with Deployer 1.0.0 that just released a few weeks ago, and so that's really exciting. Deployer 1.0.0 has a lot of changes that exist, but one thing that they're starting to talk and tell people now is do not use the mutate at or mutate if, but use this across function. And so this across function allows you to define, okay, for these columns here, apply a function. Or I think you can pass, a list of functions as well. And so now what this is going to do is, all right, for the columns 40, weight, and draft year, apply this function to it. And so it's going to first convert them into a character, into a numeric. This as characters to protect us in case there's anything that is a factor, because if you call an as numeric on a factor value, it'll give us the level of the factor as opposed to the actual value. And so that's another thing you always want to be careful about when you're dealing with factors, is that type conversion. Mm-hmm. So yeah, we get the exact same results. It's just a matter of preference.
Any player that didn't run the 40 at the combine, obviously, we're just going to remove them since they're not going to factor into this. And then here we can look at our final product, and it's we can see pretty clearly. We have players, Ellis, a hometown guy, immediately highlights it. And there we go. So we're kind of ready to get to our plot. So here I create a quick little data frame that gives us the 40 rank of each position. So I take that combine data that we just looked at, and I do a quick filter. I just took out, we're only going to look at field players. So I took out kickers, long snappers, punters, and I also took out quarterbacks. So we're just going to leave it to the players that play positions other than quarterback, really, and the specialist positions. We're going to group by draft year and position, and we're going to find the average 40 time for each season, each combine season for that position group. And then I go ahead and I group by draft year, and I add a column to the end of this called rank 40. And as we saw before, I could have arranged these and then done a row number like Cedric did. Here I use the rank function. So I say rank that average 40 column, remembering that it's grouped by draft year. And then I add a ties method here. So the ties method is basically, let's say 2 positions had the exact same rank. Let's say both offensive line and defensive line were ranked 8th that year. Ties method just says, okay, at random, select one of those and give them 8, and one of them give them 9. There's like 4 different ties methods you can use. I honestly can't tell you why I selected that one. I just did. If you don't specify a times method, what it'll do is it'll give you an average rank. So it'll basically split the difference. So you won't have like whole numbers. You'll have oh, this is a 2.5 or something like that.
Mm-hmm.
And so there's different ties methods. Always just be aware of that when you use that function, the rank function. But we got our ranks, and that's perfect. And so we can make our quick little plot sort of off the, inspired by what we saw previously from Cedric's work. 40 rank, I set the ggplot aesthetic information there. So the x-axis is going to be the actual draft year, the y-axis, the rank of the 40 for each position group. And I'm going to color each position group so that they stand out on the plot.
Mm-hmm.
Let's see, geom line, I'm going to set my line, obviously make it a little bit of a bigger size, 1.1. And then geom point, I use shape 19, and which is a filled in circle, and I set that to size 3.5. Geom text, so this is where I'm going to specify that I want to put the position group at the end of each of their lines. So the first thing I need to do is select the data that I want to use. On Cedric's plot, he actually just put in specifically, put the text at x equals, I think there was 9 races, so x equals 9. Here, the way I did it was, if let's say we wanted to do this for next season and add it to our data set, we could always do that just by changing that filter by data filter draft year. Yep. And then AES. So I'm going to set it at the x equals draft year, y equals rank 40, color and position. So I want those to obey what we saw. I actually probably didn't need to do that, I don't think, because it should be in the aesthetic because I specified it at the top. And then I did a little bit of kind of nudging with HJust and VJust so that you'll see they don't sit right on top of the grid line that I created. Similarly, because I'm using the ranks, I flip the reverse of the y-axis so that we can get 1s on top and the 9s on the bottom. And I set our breaks to be 1 to 9 by 1s. And then we create some labels. So X and Y, I'm going to leave blank. Title, rank of 40-yard sprint speed across positions. Subtitle, NFL Combine. It actually should be NFL Combine 2000 to 2020. And then caption, we'll always reference where we pulled the data from. And then here's where I theme up my plot. So I'm going to set the plot title size, and I'm going to color it white. Same thing with the plot subtitle, and same thing with the plot caption and the X and Y tick marks. I'm going to remove the legend because remember, I'm going to have each position group notated at the end of their line. And then I'm going to set the background of the plot to black. I'm going to set the plot panel background to black as well. Then the grid elements, I'm going to set the line on the grids to black, except for the panel grid major Y. So that's going to be the one that I want to see running horizontally. I'm going to actually set that to gray so that it stands out. And then plot margin. Where do we go?
So I don't know if this is. Yeah, it's an issue. I think it's a bug in our studio that we've submitted the bug where. The way if you format this in some way, it doesn't recognize that these are all linked together. So I have to run it from the top there. Not a big deal. All right, but there you go.
Okay.
Here's our plot.
And there we go.
So I thought it was fun when we looked at that, where immediately there's a delineation between running backs, defensive backs, and wide receivers, and not them.
Yeah, skill positions, and then sort of the hybrid positions, linebackers and tight ends are in the middle there, and then you have your defensive line and offensive linemen. Now, one thing to note here, and one of the values of plotting your data, one is to see what's there, but two is to sometimes spot errors or changes in the data. And so Ellis is right there highlighting the orange group, which does not go to 2020. And when we look back at this, that group is what Pro Football Reference referred to as edge players, or what I changed the name to in my if-else statements to defensive ends. And actually, if you go and look at their data, 2020 was the first year where they didn't delineate between defensive tackles, nose tackles, and edge players. They actually called all of them defensive linemen. And so there is no 2020 because effectively defensive linemen is now encapsulating those edge players. So they're all in there. So actually their rank went up. They look like they got a little faster because of the edge players. So guys like Chase Young and guys like that. Mm-hmm. So that's a really interesting one, because if we were going to do more with this, we'd have to make sure in 2020 we have a different way of identifying the edge players, the defensive ends, versus the guys that are playing in the interior.
Mm-hmm. Mm-hmm. Yeah, and then the DL and OL bumped up because
there was no edge player.
in whatever position that was too.
Oh, I think that was fullback. It was fullbacks, right? Yeah.
Yeah. Mm-hmm. So they're no longer in the 2020, so their rank automatically bumps up. It's fun. I don't know. I thought this was kind of fun to see the different the wide receivers, DBs, and running backs are kind of like they're alternating for a while there. Unsurprisingly, wide receivers were the fastest. Then one year in 2016, running backs were the fastest, and they dropped back down. It's kind of fun to see the interplay of how the different positions are speeding up or not in specific. And also noting that the data is somewhat biased because it's not representative truly of the whole college football players. These are only players that were invited to the draft.
To the combine.
To the combine, excuse me. Yeah. They're all invited to the draft.
It's about 320 players-ish, give or take, depending on the year, just based on who actually accepts the invite and goes, whether the players, who's healthy to run. Sometimes players are obviously injured and get hurt in bowl games, and that precludes them from actually running in this. So, there's a little kind of shift up and down of how many guys there are, but it's around that 320, 330. And I guess if you wanted homework, a cool thing to do would be to go back through some of the older TidyXs that we've done and wrap this in a ggplotly and have it be actually interactive, where you could hover over the dots and get, like, let's say the speed that the team ran that year. You could click on the position group and get their line colored, and everybody else maybe goes to like a grayscale or something like that. Mm-hmm. And you could investigate the data a little bit more by making it interactive. That would be a fun kind of homework assignment, I suppose.
For sure. That'd be fun. But I think that's it for today, for this episode 13. Yeah, thank you all for listening and staying with us. I think we have almost 230 subscribers, and so that's super awesome that so many of you are willing to listen to us talk about all this, and hopefully it's valuable to you. I guess once again, my name is Ellis Hughes. You can find me on Twitter at Ellis_Hughes.
And I'm Patrick Ward. You can find me on Twitter at OSPPatrick, and you can get in touch with the both of us at tidy.explained@gmail.com.
All right, thank you, and keep on exploring your world.
Boom.
Boom.